Hi guys, and welcome back to a continuation of solving worded problems. Our first type of word problems that we are going to learn is number problems. So number problems are problems about relationships among numbers, as in number problems. So the unknown is usually a whole number, not a fraction or a mixed number. So it is almost always a positive number. In some problems, the numbers are referred to as integers, which are positive numbers, negative numbers, and zero. So generally, it would be an integer. So it could also be a negative number. It could be zero. It could be a positive number. As long as these are not fraction, these are not decimal numbers, okay? So let's try to learn how we solve number problems with illustration number 1. Okay, let me show you how I solve my style of solving problems. So number 1, okay, I usually start by reading the problem and going along with translation. Okay, so there are two numbers whose sum is 72. I'll try to solve this in two ways. One that uses just one variable, and the other that uses two variables to present the unknowns. Okay, so my first solution would be using just a single variable. So there are two numbers. Let's say you have first number, which is x, and the second number, okay, which we do not know yet. But according to the problem, there are two numbers whose sum is 72. That means if we add these two, their sum should be 72. And if one of the numbers is x, therefore, subtracting x from 72, you get the other number, right? Because if you add these two, if you add them, you get x plus 72 minus x. You cancel x, you get 72 as a sum of the two numbers, okay? One number daw is twice the other number. So we just take one of the number. So let's say that would be x. One number designates an equal sign twice the other number. Ibig sabihin, doble daw nung kabila. And this is the other number, which is 72 minus x. So the value of one number is double of this one. Therefore, that is x equal to double, that's 2, times the other number, that's 72 minus x. Okay? So, solving this, you have here x equal to 72 times 2, that's 144, minus 2x. Okay? Solving for x, we transpose negative 2x to the left side. You get x plus 2x, so that's 3x, equal to 144. And then we divide both sides by 3. You get, how much is that? 48. Okay, 48. That means the first number is 48. Okay, which is your first number. Okay, and then the second number, which is 72 minus x, that would be 72 minus 48. That would be 72 minus 48. How much is that? That's 24. Okay, this is your second number. And if you're going to go back to the statement na yung isa daw number, one of the numbers ay doble nung isa, na-satisfy natin, right? Because if you multiply this by 2, you get the first number, which is 48. Okay? This is the solution. This is my solution when I'm solving with just one variable. But if you're used to solving using two variables, I can show you that. Okay? With two variables, you just normally we use x and y, diba? To represent the numbers. So let's say your first number is x. Your second number is y. The first statement says that that these two numbers have a sum of 72, which means if you add x with y, you should get 72. Okay? Aside from that, if you're going to translate the second statement, one number is twice the other, you can use one of the number, let's say x ulit, daw is twice the other number where the other number is y. Okay. What you can do here is simultaneously solving the equation. Okay, you can simultaneously solve this. The first solution is substitution. Okay, let's say by substitution. That means you're going to use one of the equations and substitute it to the other equation. So let's say I name this equation 1, this one is equation 2. Let's say I use equation 2 and since I have solved for x here, substitute x to equation 1. So what I can do is replace whatever it is in equation 1. So that's x plus y. That's x plus y equal to 72. Okay, I'll use the value of the second equation. The value of x here is 2y, and I'll replace or substitute this to the first equation. So I will replace this by the value of the second equation, 2y, and this will be 2y plus y equal to 72. And it appears to be 3y equal to 72. Divide both sides by 3. You get y equal to 24. Okay, you get y equal to 24. Okay, and then solving for x, so we were able to solve for y already. To solve for x, you can use either of these two. Okay, you can choose to use any of these two equations. But, yeah, you can use, if y is 24, you transpose it to the right, subtract it from 72, you get x equal to 48. You can use the second equation to get x, you multiply y by 2. So if I use this, because this one looks easier for me, x will be 2 times of y, and that's 2 times 24. Therefore, we get x be equivalent to 48. Okay? Yeah, that's how I solve it when I use two variables when solving. But, of course, if you're going to compare the two solutions, this one is a lot shorter than the other one. I simply just showed two methods of how you can solve it to not enclose you to specific solutions. Pero, of course, we always recommend to take the shorter route. Okay? That's all for illustration number 2. So, there are two numbers whose sum is 50, which means I can again say that the first number is x and the second number, based on this statement, is simply 50 minus x. 3 times the first is 5 more than twice the second. So, 3 times down ng first, that means I'll multiply the first number, which is x by 3, that means an equal sign. 5 more than, here comes yung pabaliktad nating solution. 5 more than twice the second number. 2 times the second number, which is 50 minus x. So, expanding the ones in the parentheses, this will be 3x equal to 100, okay, minus 2x plus 5. Transposing the unknown on the left side, you get 3x plus 2x if you transpose this. So you get 5x for that, equal to, adding constants, that's 105. In that way, we can solve for x, and x becomes 21. Okay, that means x is your first number. So let me highlight this, and let me write this, the first number. And then for the second number, that's 50 minus x. That means 50 minus 21, you get 29, right? 50 minus 21, that's 29. And this gives me my second number. Okay. Next. Separate 71 into 2 parts. Okay, hatiin daw natin si 71 into 2 parts. Separate in worded problem means that the sum, if you separate the two numbers and put them back together, they will result to 71. So in short, that means their sum is 71. So your first number could be x. Actually, you can use any variable you want, as long as you're comfortable with what you're using. The second number, therefore, is 71 minus x. It says here, we separate 71 into 2 parts such that one part exceeds, ibig sabihin labis, the other by 7. Okay? One part. So let's say that part is x, exceeds is a verb. So that suggests an equal sign and at the same time the condition. So this number daw ay labis is more than, could be, more than the other by a number of 7. So ibig sabihin, 7 more than the other number which is 71 minus x. Okay, so if we solve this, we transpose the unknown on the left side, you get 2x for that, equal to 71 plus 7, you get there 78. Dividing both sides by 2, you get x equivalent to 30, what do we have? 39. Okay, so if x is 39, that's our first number. We can solve for the second number, that's 71 minus x. And that's 71 minus 39, so we get 32. Okay, that's our second number. Okay, so as you can see, one of the number is greater than the other by 7. So that, as you can see, their difference is indeed 7. Okay, let's go to problem number 4. Find 3 consecutive integers whose sum is 87. Okay, going to the most common representation of consecutive integers, let's say we have the first, the second, and the third integer equal to, let's say, x plus 1, since integer naman to and consecutive, their difference is 1, and then the other is x plus 2. It says here that the sum of the consecutive integers should be 87. That means we simply add all of these integers, wherein the first integer is x. We add to that the second integer, which is x plus 1. We add to there the third integer, which is x plus 2. And together, their sum is 87. Okay? So, you get there 3x plus 3 equal to 87. And we get 3x equal to 87 minus 3 because we have to transpose this to the right. That would be 84. Dividing both sides by 3, you will get x equivalent to, what do we get? 28. Right? So, if we check, the first integer is 28. The second integer, which is x plus 1, should be 29. And the third integer with x plus 2 should be 30. This is the second. This one is the third integer. And if you check, their sum should be 87. So that's 8 plus 9, 17. Carry 1, that's 87. Okay, so these are our numbers. Okay, let's solve for number 5. Find 3 consecutive even integers such that the largest is 3 times the smallest. So let me write first, second, and third. Let me write here even integer. So I can write my even integer as x, the next one as x plus 2, and then the other one as x plus 4. It says here that the largest daw, which is obviously this one, x plus 4, okay, the largest, which is x plus 4, is, so that means an equal sign, is 3 times the smallest. So that's 3. The smallest integer is x, so that's 3 times x. And then if we simplify this, you will get 4 equal to 2x. I just moved in a position wherein the unknown will be positive na agad. So in short, sa halip na sa kaliwa ko i-move yung unknown, dun ko na siya nilipat sa kanan because that is the position wherein it is already positive upon subtracting. Dividing both sides by 2, diba, you will get here x equal to 4 divided 2, that's 2. Tapos ako na lang pagpapalitin ng posisyon. Or, pwede namang mentally, pagpalitin mo na agad. Diba? So, you have here x equivalent to 2. So, if the first integer is 2, the second integer should be 4, and the third integer should be 6. And let me highlight our answers. This is your first, second, and third. Sabi dito, the largest is 3 times the smallest, which is correct. If you multiply 2 by 3, you get the largest even integer, which is 6. Okay? Let's solve for the sixth illustration. 4 consecutive odd integers have a sum of 64. Find the integers. So let's say you have first, second, third, fourth. These are odd integers. Okay, you have here the first one as x. I'll let it as x. These are odd integers, so that means it's the same representation as the even. So that's x plus 2. This is x plus 3, and this one is x plus 4. If you take the sum of all these 4, you have x plus 2. Okay, consecutive odd integers means the difference between them is 2. So this should be x plus 4, and then this one should be x plus 6. So if you take the sum again, that's x plus 2, x plus 4, and x plus 6. It should be equivalent to 64. So simplifying, you get 1, 2, 3, 4x plus, you have 2, 4. 2 plus 4, that's 6 plus 6, you get 12, equal to 64. So that would be 4x equal to 52. If you subtract 12 to the right side, that's 52. And then we're going to divide both sides by 4. You're going to get x equivalent to 1 and what's that? 12 divided 4, that's 3. So your first odd integer is 13. The second odd integer is 15. The third odd integer is 17. And the fourth odd integer should be 19. And these are all our answers. Okay, so let me write here first, second, third, and fourth odd integers. Okay, and there you have it, how you solve simple number problems.